The challenge, the continuing development and expansion of the Russian Navy's anti-submarine warfare fleet. To meet the challenge, the Trident Strategic Weapons System.
In the name of the United States, I christen thee, Michigan. May God bless her and all who sail in her.
The Trident Strategic Weapons System. A system comprised of Trident I C-4 missiles in backfitted Poseidon C-3 submarines. Trident submarines with Trident I missiles. And continental United States basing and support. A system that ensures the United States a viable deterrent to nuclear war. 20 October 1979. USS Francis Scott Key, first Poseidon submarine to be converted to Trident I capability, departs from Charleston Harbor, Charleston, South Carolina, carrying 16 Trident I missiles for the first Trident deterrent patrol. 12 August 1982. USS Ohio, lead Trident submarine, arrives at Bangor Submarine Base, Washington State, to begin final preparations for the initial deployment in the fall of 1982 of a Trident-class submarine carrying 24 Trident I missiles. The overall effectiveness and invulnerability of the Navy's Fleet Ballistic Missile Weapon System has been greatly improved. The primary contributor to this improvement is the advent of the longer-range Trident I missile. The three-stage solid propellant Trident I missile has a range of over 4,000 nautical miles and an even greater range with a reduced payload. This increased range means a much larger ocean patrol area in which a missile-carrying submarine can operate, thus boosting system survivability. To permit deployment of the Trident I missile in existing Poseidon submarines, the Trident I was designed to the same basic envelope as the Poseidon missile. But key technological advances proved the Trident I clearly superior to its predecessor. The addition of a telescoping aerospike, for instance, improves aerodynamic performance of the Trident I missile. Other important advancements contributing to the Trident I missile's added range and performance are filament-mon motor chambers, high-energy solid propellants, advanced lightweight materials, and the technology of hybrid microelectronics. Development testing of the Trident I missile components began with a vigorous subsystem flight readiness ground test program. Land-launched flight testing was conducted from January 1977 through January 1979. 18 missile test flights were pad-launched from the Air Force Eastern Test Range at Cape Canaveral, Florida. The Trident I flight test program had a higher success rate than any previous fleet ballistic missile development program and achieved all major test objectives. The success of the Flat Pad Flight Test Program opened the way for the Performance Evaluation Missile, or PEM, flights in the continuing development of the Trident I missile system. The PEM program assessed the capability of the Polaris Missile Facility Atlantic, or POMFLANT, to support the processing needs of the production program. At the same time, PEM flight tests verified the missile's performance, readiness, and ability to survive underwater launches. The PEM flight tests began in April 1979. The lead Trident I backfit submarine, USS Francis Scott Key, launched a total of 7 performance evaluation missiles. The tests were completed in July 1979. The Trident I development program was now ready to enter its final phase, the demonstration and shakedown operation, DESO. Each submarine backfitted for Trident I must launch a DESO missile as a final test for the submarine crew and all systems and interfaces. The first 2 DESO tests demonstrated the readiness of the complete Trident I backfit weapon system for operational deployment. The Trident I Development Test Program, the PEM, and the DESO missiles. The final crucial steps, which led to 20 October 1979. The date USS Francis Scott Key deployed from Charleston Harbor on schedule, carrying 16 missiles for the first Trident I deterrent patrol. The Polaris Missile Facility Atlantic, located at Charleston, South Carolina, was established in 1960 as the Atlantic-based supplier of Polaris missiles to the Atlantic FBM fleet. Today, POMFLANT's mission is to process Poseidon and Trident I missiles, refurbish fleet-returned missiles, and load and offload missiles and spare components to the submarine fleet and support ships supplying the Atlantic FBM fleet. Wharf Alpha at the nearby Naval Weapons Station provides POMFLANT with port facilities for the FBM submarines. Here, the backfit submarines take on DESO missiles, and finally, their initial outload of operational missiles. Following initial receipt inspection and motor buildup, Trident I first, second, and third stage rocket motors are received at the Missile Assembly Building. In this facility, the propulsive stages are joined, and the fully mated missiles undergo final systems testing. The missiles are then ready for packaging in their environmentally controlled storage liners, available for operational deployment or for conversion to test missiles. The increased range of the Trident I missile and the resultant additional sea room available to the backfit and Trident I submarines allow them to be on station immediately upon leaving port in the continental United States, thus eliminating the need for overseas basing. The replenishment site at Kings Bay, Georgia, provides logistic support to the Trident I backfit subs of FBM Submarine Squadron 16.
Smoking lines up, frames 38 to 60, forward side main deck and above, and on the forward med deck for torpedo hatches in progress. The smoking line is out from frame 60 to 110.
The subtender anchorage at Kings Bay, located approximately 40 miles north of Jacksonville, Florida, was established in 1979 when FBM Squadron 16 moved to the United States from Rota, Spain. The squadron had supported FBM operations at Rota since 1964. All 12 Trident I backfit submarines are assigned to Squadron 16 and deployed to the Atlantic operating areas from the tender, following normal upkeep alongside the tender. The remaining force of 19 Poseidon subs operate from tenders located at Charleston, South Carolina, and Holy Loch, Scotland. Aboard the tender, second-level preventive maintenance testing, and environmental monitoring are performed to keep a constant watch on the readiness of Trident I missile components stored aboard the ship. The tender can stow 16 missiles and liners. Temperature and humidity are carefully controlled and monitored. A vital part of the support the tender offers the submarine is the operational loading and offloading of the Trident I missiles. From outward appearances, Trident I operations are identical to those of Poseidon. And in fact, both use the same basic handling equipment and similar procedures. In addition, the tender at Kings Bay is required to support Poseidon operations if necessary, as backup to the Poseidon tenders on station at Charleston and Holy Lock. Backfit conversion of the 12 authorized Poseidon submarines to the Trident I configuration began in 1978 and was accomplished at shipyards or at Cape Canaveral during normal ship's availability periods. Conversion usually took about 60 days. Conversion included minor modifications to the submarine, such as installation of improved higher energy gas generators for the missile launcher system, and conversion of the missile fire control system to all new state-of-the-art equipment. Conversion of the 12th and final Trident I backfit sub was accomplished in late 1982. By mid-year 1983, over 65 Trident I deterrent patrols had been conducted. Resupply ships called TAKs, operated by the Military Sea Lift Command, carry the Trident I missiles and missile components between Charleston and the tender, maintaining the tender at full capability and Squadron 16 at its high state of readiness. Besides weapon system components, the TAK routinely replenishes the tender supply of spare parts, torpedoes, and foodstuffs needed to provision the submarines alongside the tender during upkeep. The ultimate platforms for the Trident I missiles are the Navy's new Trident submarines. 560 feet long, 42 feet in diameter. They can carry 24 missiles, and their launch tubes have been designed to accommodate growth in later generations of missiles. At commissioning ceremonies for the lead Trident submarine, USS Ohio, Secretary of the Navy John Lehman
submarine ever built in the free world,
and Vice President George Bush spoke of the purpose and mission of the Ohio-class submarines.
Today we welcome a new ship into the fleet of the United States Navy. Over 25,000 men and women were involved in building her. The Ohio represents the latest commitment of the people of the United States to peace. Her purpose is to deter potential enemies of the people of the United States. She embodies the resolve of the people of this country that the foes of freedom attack only at unthinkable peril. In her strength lies our safety.
By mid-year 1983, 2 more Trident submarines had been commissioned into the service of the United States Navy: USS Michigan and USS Florida.
Admiral Hayward, United States ship Ohio is in commission and I am assumed command, sir.
The first 8 Trident submarines will carry Trident I C4 missiles. Follow-on Trident subs will be platforms for the larger Trident II D5 missile, planned for deployment near the end of the decade. The Trident submarines represent the highest development in submarine design and construction. They are built for quieter operation and increased speed and mobility. They have more and better sonar gear than Poseidon submarines. The Trident submarines are designed for 21% more time at sea and 40% less time in overhaul, with an expected lifespan of 30 years. Innovations in the interior design of the Trident submarine make life more comfortable for the crew. In the Trident submarines, the telemetry receiving station used in test missions is a permanent installation in the Missile Control Center. This is not the case on the Poseidon submarines. The Mark 98 Mod 2 fire control system, like the Mark 88 Mod 2 used on the Trident 1 backfit subs, is completely digital and therefore much faster and more accurate. For the first time, the launcher control and the fire control are both in the Missile Control Center, showing the launcher status and missile status side by side. The launcher control in the Tridents is of a radically new design. A new navigation control console allows the operator to monitor all phases of the navigation center. Changes in the software and console design allow the operator greater, more efficient control. The operator sees sonar and other navigation data instantaneously on the new display screen. Other major improvements include the addition of an electrostatically supported gyro monitor. By decreasing the need for position data from external sources, the new gyro monitor reduces the need for submarine exposure. The design and construction of the Trident submarine is pointed toward its final objective: the most efficient launch platform for the Trident 1 missiles and for larger missiles of the future. The Trident submarines, the United States' newest deterrent to nuclear attack. USS Ohio, lead Trident submarine, slipped into Port Canaveral at the Eastern Test Range in the early hours of 16 December 1981 to begin her demonstration and shakedown exercise, the final test before operational deployment. DESO missiles assembled at the Strategic Weapons Facility Pacific and airlifted to the Cape were loaded aboard Ohio at the Trident turning basin, a new port facility constructed especially for Trident operations. The tall mast-like structure immediately aft of Ohio's sail is a removable telemetry mast used for coordinating DESO tests with the Eastern Test Range. In the early morning hours of 17 January 1982, Ohio headed from Port Canaveral for open sea, on her way to the Atlantic launch area about 30 miles east of the Cape.
All stations control, 50 phone.
The Ohio Blue Crew was ready to launch on schedule the first Trident 1 missile from a Trident submarine. A major program milestone was about to be achieved.
Second Edition 1SQ for battle readiness exercise. This is the captain, this is an exercise.
Second Edition 1SQ for battle readiness exercise. This is the executive officer, this is an exercise.
Battle station missile for DESO WSRT. Spin up all missiles. Set up the pre-pressurized tubes 3, 22, 18, 11, 14, 6, and 23 to 5 pounds.
Con-nav weapons, navigation, fire control, transmissions checks completed satisfactorily. Navigation in condition 1SQ, weapons eye. Launcher in condition 1S2 for DESO WSRT, weapons eye.
Formation to fire. Second Edition 1SQ for launch. This is the captain.
This fully successful DESO firing was followed a month later by another DESO shot from the Ohio, while under command of her Gold crew. It, too, was totally successful. On 21 November 1982, USS Michigan, the second Ohio-class submarine to be commissioned, successfully test-fired a third Dassault missile from a Trident submarine. By mid-year 1983, 16 Trident 1 Dassault missiles had been test-fired at sea. 3 from Trident 1 submarines and 13 from Trident 1 backfit subs. The Pacific Coast home port for the Trident submarines is the Naval Submarine Base at Bangor, Washington. The submarine base is comprised of 4 commands and 1 submarine squadron. The commands are the submarine base, the Trident training facility, the Trident refit facility, and the Strategic Weapons Facility Pacific, or SWIFPAC. Together, these commands accommodate the 4 major support functions required for submarine refit, missile support, base support, and crew training and housing. As the Trident submarines become available for deployment in the Pacific, they are assigned to Submarine Squadron 17, headquartered at the Bangor base since 1981. SWIFPAC plays the important role of readying the Trident missiles for patrol or test missions. In the missile assembly building, the missiles are processed and assembled in a manner similar to operations at Palm Flat. In the vertical missile packaging building, the missiles are finally prepared for loading. They are packaged in their stowage liners and can be electrically tested. The men who crew the Trident submarines are trained here at the Trident training facility. They practice on simulators to prepare them for actual duty. The complete Trident refit facility marks the first time a training facility and a refit facility had been at the same location. The refit industrial facility, equipped with machine shops, electronic test labs, spare parts and replacement components, provides the services of a tender, while the nearby Delta Wharf on the Hood Canal provides dry dock and ship repair facilities, as well as headquarter offices for Squadron 17. In February 1982, a chapter of submarine history was completed at the Bangor subbase with the cessation of strategic operations for the last remaining Polaris submarine, USS Robert E. Lee. On 12 August 1982, USS Ohio arrived at the Delta Wharf on the Hood Canal. The 18-year vigil by the Polaris Fleet Ballistic Missile Weapon System in the Pacific would now be taken up by the Trident 1 Strategic Weapon System, and a new chapter of submarine history would begin. Following a short upkeep at the Delta Wharf, fully provisioned and with her missiles loaded aboard, Ohio departed the Bangor subbase for the Pacific Ocean operating area in the fall of 1982, marking the first Trident 1 submarine deterrent patrol. By early spring 1983, Squadron 17 had jurisdiction over its second Trident, USS Michigan, and final preparations were underway to deploy the second Trident sub into the Pacific. With her deployment for the first Trident 1 submarine patrol, the USS Ohio ushered in a new era of deterrent strength for our nation. Trident, ever vigilant, ceaselessly stalking the seas to preserve the delicate balance of peace. The challenge has been met.